Example 3. An area expressed as a limit. Let A be the area of the region that lies under the graph of f of x, which is equal to e to the negative x, between 0 and x is equal to 2. And you can see here what the graph looks like. Okay. In part A, using right endpoints, we want to find an expression for A as a limit, but do not evaluate the limit. Okay. So first thing is first, okay, we know that we're going from 0 to 2. So we're going to let A equal 0, and then B is going to equal 2. And so therefore, the width of the subinterval is the following. We know that delta x is equal to b minus a over n. Okay, so that means that we're going to take the value of 2 and then subtract 0 over n, which gives us the width of 2 over n. So what does that tell us? Well, that tells us that the width of each rectangle, which is delta x, is equal to 2 over n. And that's for each one of the rectangles that we have. Okay, so now what we want to do is we're going to say the following. So that means that x1 is going to equal 2 over n. And then x2 is going to equal 4 over n. x3 is going to equal 6 over n. Okay, which means that x subscript I is going to equal 2 times I over n. And we can say that x subscript n is going to equal 2n divided by n. Okay, so now let's find the sum of the areas of the rectangles. Okay, so what does that mean? That means if we take r subscript n, well, that's going to equal, we're going to take f of x subscript 1, and then we're going to multiply that by delta x, which is the width. Then again, we're going to take the height, f of x subscript 2, and multiply that by delta x. Plus, continuing all the way to the value of n, f of x subscript n times delta x. Okay, so what does that mean here? Well, that means that now we want to evaluate it at the function it's given, which is e to the negative x. So that means that r subscript n is going to equal e to the power of negative x subscript 1 times delta x plus e to the negative x subscript 2 times delta x plus e to the negative x subscript n times delta x. Okay, so now what do we know about x subscript 1? Well, we know that what does it equal in step number 2? Well, we know that now r subscript n is going to equal e to the negative 2 over n, because we know the fact that x subscript 1 is equal to 2 over n, and so on. So that's going to be, again, multiplied by delta x. Okay, now what is delta x? Well, we know that delta x is equal to what? 2 over n. So now we're going to replace delta x to be 2 over n. So that's going to be multiplied by 2 over n, and then plus e to the negative 4 over n times 2 over n plus e to the negative 2n over n times 2 over n, which is the width. Okay, and so now, okay, we want to be able to find and express a as a limit. So if we want to express a as a limit, then we can say that a is going to equal the limit as n approaches infinity of r subscript n, which is therefore equal to the limit as n approaches infinity of, okay, well, if we look at the previous step, can we factor out a 2n? Well, each item is going to have a 2n, so we can factor that out. Okay, and then what's left? We have e to the negative 2 over n plus e to the negative 4 over n plus e to the negative 2n over n. Okay, so now if we want to rewrite this in terms of a summation, well then what a is then going to look like is the following. A is going to equal the limit as n approaches infinity. We factored out the 2 over n, and now this part represents a summation. A summation where I is starting at 1 and it ends at n. And that means the nth term is going to be e to the negative 2n over n. And so therefore there is our a expressed as a limit. Okay, now let's take a look at part B. Part B, it says estimate the area by taking the sample points to be midpoints and using 4 subintervals and then 10 subintervals. Okay, so let's take a look at this graph here. Okay, so here's our graph. Okay, and we're estimating by taking sample points using 4 subintervals. So let's talk about that there. So in step number 1, that means that n is going to equal 4. And so we're dealing with midpoints here. Okay, so if n is equal to 4, and if we're looking at this situation where we have, this was 2 over n, in this case, this is 4, so that means that we're going to be going in the midpoint. So that means that in the midpoint between here and here, this is going to represent 1/4, or 0.25. Okay, and then here we have 3/4, which is in the middle there, which is 0.75. And then over here, we're going to have 5/4, which is the same thing as 1.25. And over here, this is going to be 7/4, which is the same thing as 1.75. So those represent the midpoints of the rectangles. So again, let's take a look at that here. So this represents a midpoint. So those are midpoints of the rectangles. Okay? So now we also need to talk about the width. So remember that delta x represents the width. That means that we're going to take b and then subtract a and then divide it by n. Well, we can see here that b represents 2 and a is 0. and we know that the value of n, which are the rectangles, is 4. So that means the width is going to be 2/4, which reduces to 1/2. Okay, so if we want to represent this as the midpoint, and we'll put M4 since that's what we're using, 4 rectangles. Okay, well what that's going to equal is the following. We're going to take 1/2, right? So we're going to find f of 1/4 times the width, which is 1/2, plus we have f of 3/4 times 1/2, plus f of 5/4 times 1/2, plus f of 7/4 times 1/2. So if we factor out the 1/2, then that means that f of 1/4, okay, is the same thing as 0.25. And if we're using our function, remember that our function is e to the negative x. So that means that if we take a look up here, it's e to the negative x. So therefore, this is going to become e to the negative 0.25 plus e to the negative 0.75 plus e to the negative 1.25 plus e to the negative 1.75. Okay, and then when we multiply that all out, then we get an area of 0.8557. So that is using the midpoint of 4 subintervals. Okay, so now let's go ahead and try the 10 subintervals. So here's our graph for the 10 subintervals. Okay, so let's go ahead and do that. So if we're going for the 10 subintervals, we know that n is going to equal 10. Okay, so if we're looking at n is equal to 10, we're going to use midpoints. So remember that delta x is going to equal b minus a over n. We know that b is 2. We're going to subtract a, which is 0, and now this is over 10. So this is 2 divided by 10, which reduces to 1/5. Okay, so if that means that the edge of these, if this is 2/10, this is 4/10, okay, and this is 6/10. Okay, what this does is this allows us to see what our midpoints are going to be. So therefore, our midpoints here represent 1/10. Okay, and then the midpoint here is going to be 3/10. And then here we get 5/10. And then 7/10. And then we have 9/10 here. And then 11/10. 13/10. We have 15/10, 17/10, and then 19/10. Okay, so now let's go ahead and find our midpoint. Okay, so when we want to find our midpoint, we know that we're looking for M10. So we know that we take the value of 1/5, which is the same thing as 2/10, but in this scenario, this would be f of 1/10 times 1/5, or 2/10. So we'll write that as 2/10. And then plus f of 3/10 times 2 over 10 plus dot dot dot, we're going to go all the way to f of 19 over 10 times 2 over 10. Okay, so if we factor out the 2 over 10, we know that that reduces to 1/5, so we have 1/5. Okay, and then we know that f of 1/10, 1/10 is the same thing as 0.1. So what does that mean? That means that we have e to the negative 0.1 plus e to the negative 0.3 plus e to the negative 0.5 plus e to the negative 0.7 plus e to the negative 0.9 plus e to the negative 1.1 plus e to the negative 1.3 plus e to the negative 1.5 plus e to the negative 1.7 and plus e to the negative 1.9. Okay, and so now when we do this, okay, we multiply that all out, we get that the area for the midpoint of 10 rectangles is 0.8632. And so recall what happened here is, in order to find x1, okay, that was equal to x subscript 0 plus the change in x. X subscript 2 is going to equal x subscript 0 plus 2 times the change in x. And then x subscript 3 is going to be x subscript 0 plus 3 times the change in x. Okay, all the way to, if we consistently did this, all the way to the value of I, that means that x subscript I is going to equal x subscript 0 plus I times delta x, which is the width, which ends up being 2I over n. Okay, now that we finished that, I just want to go back to this one over here. Well, notice that between 0 and 1, this is actually 1/2, or this is 2/4. Okay, and then we have 1, which is the same thing as 4 over 4. Okay, and then over here, this is going to be 1.5 between 1 and 2. Well, 1.5 would be 6 over 4.